Hello everybody, welcome to my class. So today I am going to discuss about a topic from vertical circle and vertical circular motion. So you can see in a bit different form of the vertical circular motion. So here I am going to discuss about vertical motion on the outer surface of an arc of a circular track in the form of a sine curve. Means sine curve is something like that. It's okay? Alright. So let's now see. For example, here we consider part of a circle, means we are taking the two identical circles, that is the part of two identical circles in the form of sine curve. For example, it is like this, and suppose it has center somewhere here at this point. So this is the radius of this circle R, and we keep the same radius for the another circle also R, so that the circle will be identical and this is the same line. And this is angle theta, which is subtended at the center, that is scribed angle is theta in both the cases. Now suppose that this is A, this is O, and this position is B, and A, O, B all lie along the same straight line, and if you consider this to be potential energy equals to 0, that means A, O, B all are from the same height about this center. So you call the first circle center as C1 and the second center as C2. Okay? So what we are concerned to discuss about that, what will happen when an object is here. From here, if you provide some velocity u, for example, at this point, then you have to see that how does this object completes this sort of vertical motion while reaching from A to position B. So in this case, let's suppose that some object is here at this point. It's okay? So here at this point, you can see that this particle will not lose the contact between A and O. But however, between O and B, you will see that it may lose the contact with this surface. Okay? Provided if there is some external force acts on this body. So at this point, we will see that the nature of the motion so that this particle or this body will not lose contact with this circular path while reaching from position O to B. Alright? So let's suppose the body has reached at this point O. Now just go ahead and O. At this point, suppose that it has velocity V1. And after the very nearest distance, it has some velocity v2. Now compare these two velocities while rising the height by this object while going through this track. So at this point, what you can see clearly that v2 is less than v1 because there is no external force. Just because of this speed provided to this object. So you see that they are at the same level, so speed at this point and this point will be same. That we'll see very soon while going through the law of conservation of energy in this case. So at this time I am concerned about when this particle is here and as it is rising O about this up to the top, what you see at each and every point the velocity is decreasing. So V1 will be bigger than V2, and also if there is V3, then V3 will be bigger than V2 will be bigger than V3, or V3 will be less than V2, and so on like this up to this position. At this point, the velocity will be very close to 0. That will be at the maximum point. The object will be at the slowest motion. Alright? And after that, it will again start to regain the motion. This is straight. So let's talk about between these two consecutive positions. position, you have now clear that V2 is less than V1. That means what? V2 square is also less than V1 square, because we are taking V1, V2 all in positive sense. So what is the objective of this? And you know that the mass of the object is m. So if you multiply both sides by half m, and here also by half m, in that case you'll see that this is V2 square, then this is less than V1 square. That is kinetic energy for V2 say 2 is less than kinetic energy by this motion V1, due to motion V1 is KE1. So you see that while rising from position O2 up until the top, every time there is decrease in kinetic energy, that is the loss of kinetic energy, and that loss of kinetic energy will cause the body not to leave this surface throughout this motion from position O to B through this arc. So what we finally see that this loss of kinetic energy inhibits the particle, this particle I mean, chance to escape the surface, and hence it does not escape the arc OB at you can call this as OB at O. In fact, it will never escape the trap. So let's make it even clearer by one example of this sort of circular motion. Here is an example. A particle is projected from the point A. You can call this point A, and this is O, and this is B. So let's read out the question first. A particle is projected from the point A with a speed u along a track that is made up of two identical quarter circles. What are these? The quarter circles of radii 30 meters each. As shown in this diagram, find the range of values of u such that the particle reaches B, that means the position B over here, without losing contact with the track. So in this case, what the question says that a particle is here at this point and it has to move through this outer surface of this two identical quarter circle track which is standing vertically. Alright? So in that case, its start velocity is, for example, it is u over here. Then what is the, according to the question, you have to find what is the range of value of u so that this particle completes this motion up to position B without leaving the contact with this circular track. So that we have to find it here. So in this case, what we can use the two conditions. One condition by the law of conservation of energy, then we will see that one of the range of value of u, then by another condition of other sort of forces, for example reaction and the weight of the body, and then we will see that what does that end the range of value for u, and between those maximum and minimum we say that this should be the range of value of u so that the particle will complete this circular motion. It starts from A to B without leaving the contact with this surface. Alright? So let's see here, for example, there are two circles and you said that the quarter circle, that is what happens, the scribed angle must be here 90 degrees and here also 90. It's okay? So this is by geometry you can say. Now consider this is the zero potential level. Okay, you can consider that as at some point. For example, at this center we consider potential energy equal to 0. That means you compare the energy about this C2 point, or the C2 depth, or the C2 height from C2 of this track. So at this point, what we see first, that okay, so we start from here. If the particle is here at this point, it has been given velocity u. So what you see, actually the reaction will always act normal to this surface, and because its mass is m, then because of the gravity it acts vertically downward as m. Now we are concerned with to find the velocity at this point. So the physical condition is that because A, O, B all lie along the same straight line and with about the same height about C2. So if you compare the points A and O, the velocity at A will be equal to the velocity at O. This can also be evident by using the law of conservation of energy, firstly at these 2 points. So let's see what happens. We call that total energy, firstly by what you say, by the law of conservation of energy. What you can say, choose the point A and O at this time, because we are going to compare the value of u at A and O, whether they are same or different between A and O. So what you can say by this law, total energy at A equals to total energy at O. Total energy means what? Kinetic energy at A plus potential energy at A equals to the same thing, kinetic energy at O plus potential energy at O. So what is the kinetic energy? For example, at A, you call this energy as velocity as UA, for instance. Okay, or it is given U. So as the velocity at A, that is at the initial point, is UA, so kinetic energy will be half times mass of the body, UA square. And now potential energy means, you know that the potential energy is, in fact, potential energy is the work done, that is the force times the displacement. Alright, that is the energy possessed due to the position of the body. So force in this case, if you see, the force is mg. Then what is S in this case? So you have to work out S from this sort of situation. So S means what here? This height. So this height means from here the particle is at this point, so this is the height, and parallelly if you go like this, this will be equal to this height. Alright? Now as this is the radius of the circle, these two lines are equal, so OC to B is an isosceles triangle, so height is the perpendicular height from this to this. In fact that by the property of isosceles triangle, you see that if this is perpendicular, then it will bisect this line and also it will bisect this angle. Okay? So whole angle is 90 degree, that means this angle is now 45 degree, on our side is also 45 degree. Now we are concerned to find this height, that means this height, that means you have to find this length. So use the trigonometry for this angles 45 degrees. So what you can see, cos 45 degree, you can call this as h. Okay, so cos 45 degree is in fact the adjacent side by the hypotenuse. Yes, so adjacent side at this point is h, and the hypotenuse is now, this is the radius. In fact, this is 30 meter. So this is 30 meter. That means your h value is 30 cos 45 degrees. Okay, and you know that cos 45 degree is 1 by root 2. So what you can call here, 30 by root 2 also. That means we have found this height h as 30 divided by root 2. So let's go back now. Yes, mg and height is now here 30 root by root 2, or we can write 30 cos 45 degree as you like. So this is 30 cos 45 degrees. Now at this point, now we are on the another side. At this point, say the velocity as uo, okay, at point O. So the kinetic energy at that point will be, due to the motion, half m uo square, and the potential energy is plus now half, no, this is m g, and the height is still the same here. So this value is 30 cos 45 degrees. So we can write here times 30 cos 45 degrees. And from both the sides, you will see that this is mg cos 45 degrees and mg cos 45 degrees. They are now cancelled out, so that what you see, like half m ua square equals to half m uo square. These are remained here. Now again you can see here that from the both sides, half m and half m, they got cancelled out. So what we are left with, ua square equals to uo square. That means you have both sides square cancelled. You can also write uo equals to ua, and it is given that the velocity at a is u. That means when you have the velocity or the speed at point u is debated equalistic speed, point at a is u, then also at o, what we have found, this is also u. That means whatever is the velocity over here, or the speed over here, so after this motion, okay, there will be the same speed at this point that we have seen. Now we talk from this point to this point of the motion of this particle without having living contact with this track. So what did we see here, that the velocity or the speed by which the particle is projected at this point had the same speed at point O. Now let's talk about point O and the top of this track. Okay, so at this point what happens? So at this point now again the speed is u. So if you consider again by, you can say again by the law of conservation of energy, we call it like total energy at this position O equals to total energy at this top position. Okay, and we have earlier seen that the total energy means we are talking about total sum of kinetic energy as well as the potential energy. So at point O, you can see the kinetic energy is now half m u square, and the potential energy is mg times, the height is the same again, h is now 30 cos 45 degrees. So this is 30 cos 45 degrees, and then equal to total energy at the top. Suppose that this particle has velocity v at this point. It does have some velocity v at this point. So you have now kinetic energy at the top, half m v square plus mg. Now what is the distance about this zero potential level? In fact, this is r, this is r, this is the part of the, this is circular arc of this circle, so that this height will be now equal to r, which is 30. It's okay? So that in this case you can write here the height as r means here 30, that means 30 mg. Now separate v square now So after solving it, you will find v square equals to u square plus 30 root 2g minus 60j. Now look at here, as we are concerned with that this object should complete this motion up to B without losing contact with this surface. So you can see that from this point, as the object is rising up and up, so there is decreasing kinetic energy, and at the highest point the kinetic energy will be maximum, will be minimum, alright, and the potential energy maximum. So if this is the minimum velocity, you will see that it is very close to 0 but not 0, for example. If it is 0, then it will not move. So what you call here, at this point, if the velocity is not equal to 0, this is slightly bigger than 0, then what happens? The particle will move to another side from this top and it will reach to B. Okay? So in that situation, we see that what is the value of U. So here let's consider V is greater than 0. Okay, so that what you see, u square plus 30 root g root 2g minus 60g, where you can take g as 10 meter per square second. This value is. This is greater than 0, and after you solve it, you will see that the value of u is greater than near 13.3 meter per second. Okay, 3 meter per second. If you consider this value correct to 3 significant figure, what does it mean? It means that in order to have this particle to complete the entire motion up to B, especially we are talking from O to B at this point, the projection speed must be bigger than 13.3. Only then the body will complete the motion, otherwise the body doesn't complete this motion up to B. Right? So note it down. Now we note that the value of this projection speed must be bigger than 13.3 in order that the body will complete this motion up to B through this track without losing contact with the quarter circular path from outside. Okay. Now we analyze about another condition at this point. So what you see here is that its weight always acts vertically downward by the amount mg, and the reaction will be directed towards this center. In fact, it will be the normal to this point on the surface. So this is the reaction. Okay. Now, which force is responsible towards the center C2? Okay, that force will give you the centripetal force towards C2. So we consider this centripetal force because our track is in this circle. Alright? Then what you call, look, this is 45 degree, and you can see these two are parallel line, so that this will also be alternatively it is 45 degrees. Okay? Got it? Now when you talk about the component of this mg, means this is mg, this is 45 degrees, so the horizontal component for mg, not for all, but for mg is now mg cos 45 degrees. Okay, and it has vertical component at this point as mg sine 45 degrees, and then it will be balanced by some other force towards opposite of this mg sine 45 degree direction. And we see that if we need, then we use this value, otherwise we'll leave it in its balanced condition. So at this point, what you can see, so let's go further. At position O we are talking of, at position O we are talking of. Look at here now. The one force towards the center C2 is mg cos 45 degrees, and another force R is just opposite to that. This force mg cos 45 degrees. Now, if you consider the force towards C2, this amount of force must be positive towards C2. That means this amount should be greater than 0. And this would be equivalent to the centripetal force. And you know that the formula for centripetal force is mv square by r. So it is m and v for this object is u now at this point. So what you write here, m u square by, and what is r? R is 30 meter. So you write here 30. Okay. And next, if the particle leaves contact at O, then what happens? R must be equal to 0. So R0 we are taking that what would be the minimum value of R so that the particle is just about to leave this contact. Okay, not more than that. So for instance, we are supposing that R equals to, if R equal to 0 is at any point, then this particle will lose the contact. Okay, so we are talking at this point. If R is 0, then the particle loses or about to lose the contact with this track. So on the basis of this assumption, what you get here, therefore you see that g means you can take the value as 10, cos 45 degree is now 1 by root 2, and r we are taking 0, and the centripetal force is now u square by 30, that is r, and this will give you the value of u as 14.6. If you solve this for u, you will get that this is 14.6 meter per square per second if you use your calculator or otherwise, and if you express that up to 3 significant figure, then at the condition of r equal to 0 at this point, you will see that the particle will be about to lose the contact. So on that basis, our value of u is now 14.6 meter per second. So what you think about? In order to keep that particle in contact with this track, u provided at this point must not be bigger than this, bigger than or equal to 14.6. Alright? That means what? At this point, the particle will not lose the contact only if u is less than 14.6 meter per second. So at u value at this point equals to or bigger than 14.6 meter per second, the particle will definitely lose this contact. But if the velocity or the speed provided, amount of speed provided at this point is just less than 14.6, then it will guarantee that the body will not lose the contact with this track when it moves from the point O to B. Now let's do the conclusion. So here mathematically you can see that the value of u must be bigger than 13.3 meter per second, and it must be less than, you can see, 14.6 meter per second. So if the value of u is between these two values 13.3 and 14.6 meter per second, then you will see that this particle will complete this whole circular motion. And this sort of thing you can see applies in case of roller coaster as well. I hope all of you have seen the roller coaster. So guys, I hope we answer this question that it says that find the range of values of u such that the particle reaches B without losing contact with the track. So guys, this is all for now, and thanks again for your patience.